Hello guys, welcome back. This is the next network tutorial. It's going to be about subnetting. So I have a few topologies here and some questions. So let's try to answer them. So for this topology, the first question is how many subnets are needed? The subnet number of subnets needed depends on the number of interfaces the router is connected to. So if we count, we get 1, 2, 3, 4, and 5. So therefore 5 subnets. Next question is how many bits must be borrowed to support the number of subnets in the topology table. Number of networks that can be split depends on uh, is actually it can be done only in the powers of 2. So you get 2, 4 and 8. So to support 5 we can't use 4, so you have to use 8, and 8 is 2 to the power of 3. So we need to borrow 3 bits. The next question is how many subnets does this create? Since we are borrowing 3 bits, it's 2 power 3, we get 8 subnets. But we need only 5, so the remaining 3 are not used. So how many usable hosts does this create per subnet? Usable host is number of 2 to the power of number of subnets. That is uh, that is 2 to the power of 5. So we get 32. The first one is the network address and the last one is the broadcast address. So subtracting 2, we get 30. Then calculate the binary value for the first 5 subnets. So as you can see here, uh, these these 5 bits decide the these 5 bits are used to name the PCs and other things in the network. These 3 bits belong to the network. Uh, so these 3 bits will be changing. So it will be 0 0 0, then 1, then for 2, 3, and so on. So that's how we get binary digits. Cal Calculate the binary and decimal value of the new subnet mask. So the new subnet mask, we have borrowed 3 bits. So it should actually end here. Only these first 3 octets would be 1, and the remaining should be that of the IP address. But now we borrow 3 more. So this is 255, 255, 255, and the first 3 bits borrowed is 224. Then the next one is fill in the subnet table. And then they're asking us for the first host address, last host address, and broadcast address. So this, so a network address, there are 32 networks. There are 32 hosts in each network. So the first one will have 0 to 31. Next one will have 33 to 63, and so on like that. And the first host address is the one after this, that is 192, 168, 100 and 1. The last host address is the one prior to this. Uh, sorry, the last host address is 2 numbers prior to this. So it's 192, 168, 100 and 30. The last address is the broadcast address. So now we come to scenario 2. Again, how many subnets are needed? If we count the interfaces, we get 1, 2, 3, 4, 5, 6 and 7. So we need 7 subnets. How many bits must be borrowed? Again, it can be only done in powers of 2. So 8 subnets will be created. We use only 7. So for 8 subnets, it's 2 to the power 3. So 3 bits should be borrowed. How many subnets does this create? 2 to the power 3, which is 8. How many usable hosts does this create? So again, it's 2 to the power of 5 minus 2, because 8 bits are there in the last octet, 3 are borrowed, remaining 5 are there. So 2 to the power 5, 32. And the first one and the last one can't be used. So it's 2 to the power 5 minus 2, and we get 30. Calculate the binary value for the first 5 subnets. So again, similar to the previous one, the last octet is written in 8 bits, but only 5 bits are used for providing IP addresses. The first 3 are used for the different subnets, and again it ranges from 000, 001, 2, 3 and so on like that. Calculate the binary decimal value of the new subnet mask. Again we borrow 3 bits, so this would be a new subnet mask. And the decimal value, if you convert it, we get 255, 255, 255, and this is 224. And again there's a subnet table. This is our address. Again there are 32 IPs in each subnet, so it's 0 to 31, then 32 to 63, and so on like that. The first host address is 1.1. The last one is two things prior to this, because that's the last usable one, and the last one is actually 0.31, which is the broadcast address, but that can't be used. That's it, guys. Thanks for watching.